এই সরি বাবু, সরি, একটা বড় ফোন কল ছিল, একটা বিশাল বড় কলেজ থেকে একটা ফোন ছিল। এই লেখো, সরি, এই লেখো, হেডিং দাও, রিং, রিং অ্যান্ড ফিল্ড, রিং অ্যান্ড ফিল্ড, রিং অ্যান্ড ফিল্ড। লেখো, ফার্স্ট লেখো রিং। Let capital R be a non-empty set. Let capital R be a non-empty set and plus and dot, plus and dot be two binary compositions defined on R, defined on R. Defined on R. Not necessarily this plus মানে addition or this dot মানে multiplication, not necessarily. Then R is said to form a ring. Then R is said to form a ring if the following conditions are satisfied. Number one, first is this. Number one, R comma plus is commutative group, is commutative group. Number two, R comma dot, dot is the second operation and plus is the first operation, and R comma dot is semi group. R comma dot is semi group. And number three, for any three elements ABC in R, for any three elements ABC in R, A dot B plus C, A dot B plus C is equal to A dot B plus A dot C, and B plus C dot A is equal to B dot A plus C dot A. And this মানে distributive law holds. লেখো, this ring is denoted by, this ring is denoted by R comma plus comma dot. So actually there are 9 conditions. Commutative group মানে there are 5 conditions. Semi group মানে closure and associative, and this is, there are 2 conditions here. There are 2 conditions. So total number of condition is 9. Now I shall add one by one condition here. It is semi group মানে closure and associative. One by one conditions we shall add here, then name of the ring will be changed. লেখো, if in the ring R comma plus comma dot, if in the ring R comma plus comma dot the operation dot is commutative, the operation dot is commutative, then the ring is said to be a commutative ring. Next definition লেখো, if in a ring r plus dot, if in a ring r plus dot if in a ring r plus dot identity element exists, identity element under the operation dot, because under plus operation there is identity element, under the operation dot exists, then the ring is said to be ring with identity element. It is said to be ring with identity element. Now I দেখো, if in this ring identity element exists, inverse of every element exists, and it is commutative, then this ring will become then r dot will become actually commutative group. So that means when r plus is commutative group, r dot is commutative group, and distributive property holds, then it will be filled. So if only commutative property hold, then it is commutative group. If identity element exists under the operation dot, then it is ring with identity element. And if inverse identity element and commutativity property holds, then we shall say that it is a field. So write independent definition of field. definition লেখো field, field লেখো, let f be a non-empty set, f for field actually, let f be a non-empty set and plus and dot be two binary compositions, defined in f then f is said to form a field if the following conditions are satisfied. Number one, f plus is commutative group. Number two, f minus 0 dot is commutative group. Number three, for any three elements a, b and c, a into b plus c is equal to a into b plus a into c. for dot operation I have excluded the identity element 0 from F set because 0 has no inverse under dot operation. This 0 is identity element under F. So here actually দেখো, this is field and here it is ring. In field there are total 11 conditions, 5 and this is 1. So total 11 conditions are there, whereas there is 5 to 7, and if I take this is one condition, then there will be 8 conditions. 8 conditions. Now in your question paper you will get this type of question. Suppose a ring is given, you have to check whether it is a field or not. A ring is given, you have to check whether it is a field or not. How can I check? How can I find it? এই দেখো, so 8 conditions are in ring and there will be 11 conditions in field. What will be the remaining 3 conditions? Just we shall use this remaining 3 conditions. Identity element must exist. Identity element must exist. Inverse of every element must exist, and commutative property holds. So just I shall check these 3 conditions from ring, then it will become field. Then it will become field. I now let question লেখো, question লেখো. If in a ring r comma plus comma dot, if in a ring r comma plus comma dot, if in a ring r comma plus comma dot 0 be the additive identity element, 0 be the additive identity element, মানে 0 is identity element under the operation plus. If 0 be the additive identity element, then prove that this thing a into 0 is equal to 0 into a is equal to 0. Number 2, a into minus b is equal to minus of a into b. Number 3, minus a into b is equal to minus of a into b. And number 4, a into b minus c is equal to a into b minus a into c. We shall prove this. Very simple proof, very simple proof. দেখো, number 1 লেখো, since 0 is identity element under plus, since 0 is identity element under plus, therefore we have 0 plus 0 is equal to 0. 0 plus 0 is equal to 0. I shall prove this thing, a into 0 is equal to 0. So we shall multiply both sides by a So a into, it is 0 plus 0 is equal to a into 0, that is a into 0 plus a into 0. This is by distributive law. In ring it is possible, and I can write a into 0 plus 0. So this implies a into 0 cancel karo. We have done in group theory, cancellation law holds. So it is a into 0 is equal to 0 by left cancellation law. By left cancellation law. Number two, I shall prove. This is your homework. You will do. This part is your homework. This part is your homework. Lekho. We have b plus minus b is equal to 0. This implies I multiply karo by my a. So a into, it is b plus minus b is equal to a into 0. This implies a into b plus a into minus b is equal to a into 0. We have already proved it. A into 0 means 0. We have already proved. I can write it as a into b plus a into minus b is equal to a into b plus, it is minus of a into b. A into b. Here also we can use left cancellation law. So a into minus b is equal to minus of a into b. Using left cancellation law. Using left cancellation law. Using left cancellation law. Next level. I देखो this thing, what are you getting? Minus a into b is equal to minus of ab. This is your homework, almost same. Now I shall do this thing. देखो a into b minus c, this is equal to a into b plus minus of c. So this is equal to a into b plus a into minus of c. By distributive law, lekho, by distributive law. So this is equal to a into b. This I have just proved. This question, it is minus of a into c. Minus of a into c. I clear, Babu? I clear? Any problem? Any problem, student? Please. Am I audible?
No, sir, no problem.
Follow, please. I next level. I let so that the set of all integers, so that the set of all integers forms a ring, forms a commutative ring under the composition O and star. This is first composition, this is second composition, where where A O B is equal to A plus B minus 1 and A star B is equal to A plus B minus A into B. So this is first operation, it is second operation. We shall show that it forms a ring. Ring মানে under first composition it is a commutative group, under second composition it is semi group, and then distributive property holds. লেখো
স্যার কোশ্চেন একবার বলবেন?
কি লিখেছো, কি লিখেছো বলো
স্যার
দেখি।
ওই আন্ডার দ্য কম্পোজিশনের পর একটু বলুন।
তুমি কি লিখেছো সেন্টেন্সটা পড়ো না পুরোটা, কি লিখেছো।
স্যার মানে আমি লিখেছি কমিউটেটিভ রিং আন্ডার দ্য কম্পোজিশন 0
Star and this under the composition star and O and star where O এর definition এটা, star এর definition এটা।
ওকে স্যার।
Okay, let Z be the set of all integers. Let Z be the set of all integers and A, B and C be any three elements. A, B and C be any three elements of Z. Any three elements of Z. Therefore, number 1, AOB is equal to A plus B minus 1. This belongs to Z since A comma B belongs to Z implies A plus B belongs to Z and A plus B minus 1 also belongs to Z. A plus B minus 1 also belongs to Z. Number 2, এই অ্যাসোসিয়েটিভ চেক করো। AO BOC this is equal to AO BOC মানে B plus C minus 1. So this is equal to, calculate করো, this is it is first element plus second element minus 1. So first element plus second element minus 1, that is A plus B plus C minus 2. A plus B plus C minus 2. And then A, B, C, this is equal to this equal to this is A plus B minus 1 plus C, that is A plus B minus 1 plus C minus 1. So it is A plus B plus C minus 2 minus 2. Therefore, AOBOC is equal to AOB OC. Therefore O is associative. O is associative. Number 3, identity element check করো। আচ্ছা, এ ও E1 is equal to A. This implies A plus E1 minus 1 is equal to A. So it is E1 is equal to A. This is integer. And next is, this is E2 OA is equal to A. This implies E2 plus A is equal to, E2 plus A minus 1 is equal to A. That is E2 is equal to 1. Therefore E1 is equal to E2 is equal to 1. Therefore 1 is the identity element under the operation dot. 1 is the identity element under the operation dot. Now inverse element check करो, inverse element check करो. Number 4, A O A dash is equal to 1. This implies A plus A dash minus 1 is equal to 1. That is A dash is equal to 2 minus A. And left inverse is A double dash O A is equal to 1. So therefore A double dash plus A minus 1 is equal to 1. So here also we are getting A double dash is equal to 2 minus A. Therefore 2 minus A is inverse of A. Inverse of A. 2 minus A is inverse of A. Therefore inverse of every element exists in Z. This is number 4, under the operation O. Number 5, you have to show this, you will do this. A plus B is equal to A plus B minus 1. So we can write it as B plus A minus 1. That is BOA. Therefore O is commutative. I দেখো, so under O operation commutative group it is formed. Now under dot operation check करो. Under dot operation it will be semi group. Number 6, A star B is equal to A plus B minus AB. It is integer. Since A comma B belongs to integer implies it is A plus B belongs to Z, A into B belongs to Z. Therefore A plus B minus AB belongs to Z. Number 7, this is your homework. You will show this. We have done this in group theory. Same operation I have done in group theory. A star B star C is equal to A star B star C. This is your homework. You will do. So therefore star is associative. Now identity element, distributive law check करो. This is देखो, when plus and dot are the two operations, your distributive law was A dot B plus C is equal to A dot B plus A dot C. So here it will be the second operation. So A star BOC, this you have to show that this will be same as, you have to show that it is A star B O A star C A star C. So A star BOC mane A star BOC mane this is BOC mane this thing. What is this? BOC mane it is B plus C minus 1, B plus C minus 1. So this is equal to A star this money, using this operation it will be A star first plus second minus first into second this. So this will become A plus B plus C minus 1 minus AB minus AC plus A plus A. I just this you have to show, it will be same thing. A star B mane it is A plus B minus AB this. A star C mane it is A plus C minus AC. So this will become O operation mane it is A plus B minus AB plus A plus C minus of AC minus 1 minus 1. So देखो they are equal. So लिखो therefore I finally लिखो therefore A star BOC is equal to A star B O A star C A star C. Another thing is this, you have to this. I দেখো another distributive law was it is B plus C dot A is equal to B star BOA B dot A plus C dot A. So that means here it will be this is B this
So,
O বলো
so can you please repeat that last line, sir? A star B dot C is
এই
equals
লেখো
to.
তুমি প্লিজ try to write it. How you have to do this now? What are you copying just? Why not doing yourself? This is B star C. What will be result? Everything you will copy. Don't do anything. Try to do. What is this? What will be this? You can I think fill up. Try to do. Everything you have to copy. So this will be দেখো. So BOC star A, this will become you have to show this will become B star C, this will become B star C, sorry, B star A O C star A. You have to do, you will calculate this, they will be equal. So that means distributive law also holds. Lekho therefore Z forms a ring under O and star. Z forms a ring under O and star. Just I write a homework. Write a homework. Sorry, just a minute. I shall give you homework. Like this. I write a homework. You will do this. You will do this. So that so that the set of all matrices so that the set of all matrices of the form this set of all matrices of the form A B 0 0 A B 0 0 where A and B are integers where A and B are integers forms a ring under matrix addition and multiplication under matrix addition and multiplication. This is your homework. This is your homework. You will do this. Keep till here. Have you anything left? Is this syllabus complete or there is something left? Then I have to do class tomorrow. I bolo, have you done anything more in your college which you have not done till now? এই তোমরা কিছু করেছো কলেজে? আমরা কমপ্লিট করলাম সিলেবাস না আর কিছু বাকি আছে?
স্যার মনে হয় কমপ্লিট হয়ে আছে।
তাহলে তোমাদের পরীক্ষা কবে?
স্যার ম্যাথস পরীক্ষা তো 16 তারিখে।
তোমাদের ম্যাথস এক্সাম 16th, তাই তো?
স্যার তার আগে তো কোনো সময় নেই।
তার আগে কি পরীক্ষা আছে তোমাদের নাকি? 15th পরীক্ষা আছে?
স্যার 14th পরীক্ষা আছে, ম্যাথসের জন্য একদিন ছুটি দিয়ে।
ও তাহলে ঠিক আছে, তোমরা করো। তোমাদের এবারে কোশ্চেন প্যাটার্নটা অন্যরকম হবে শুনলাম। তোমাদের প্রবলেম আশা করি হবে না। যদি কোনো প্রবলেম হয় আমাকে ফোন করো, ফোন করে জিজ্ঞাসা করে নিও। মানে করতে করতে কোনো প্রবলেম হলে আমাকে ফোন করে নিও, আর না হলে হোয়াটসঅ্যাপে লিখে দিও, আমি চেষ্টা ট্রাই করবো, সময় পেলে করে দেবো। ফোন করে জিজ্ঞাসা করে নিলেই সেটা বেটার আমার মনে হয়, সঙ্গে সঙ্গে অ্যান্সার পেয়ে যাও। অনেক সময় হোয়াটসঅ্যাপ করলে আমি করে উঠতে পারি না, সময় বিভিন্ন কাজের মধ্যে থাকি তো। হ্যাঁ ঠিক আছে, তাহলে তোমাদের সিলেবাস কমপ্লিট করলাম। আমি তোমাদের কিছু নোটস পাঠিয়ে দেবো, তোমরা একটু এক্সামের আগে একবার দেখে নেবে কিছু, ঠিক আছে? সো টুমরো উই উইল হ্যাভ নো ক্লাস। থ্যাংক ইউ ভেরি মাচ, থ্যাংক ইউ অল ফর কোঅপারেটিং।
হয় ওই ভেক্টরটা করা হয়।
হ্যাঁ
ভেক্টর
ভেক্টরে কি করা হয়নি? আমরা আইগেন ভ্যালু আইগেন ভেক্টর করিনি?
স্যার ওটাই করে হবে তো?
হ্যাঁ বলো।
না স্যার ঠিক আছে।
আমরা আইগেন ভেক্টর করেছি কি? আইগেন ভেক্টর, আইগেন ভ্যালু, লিনিয়ারলি ডিপেন্ডেন্ট, ইন্ডিপেন্ডেন্ট।
হ্যাঁ হ্যাঁ স্যার, ওইগুলো
করেছো তো? হ্যাঁ ঠিক আছে ঠিক আছে ঠিক আছে, তাহলে আর কিছু থাকছে না। ঠিক আছে ঠিক আছে ঠিক আছে বাবু, থ্যাংক ইউ অল, থ্যাংক ইউ। সো ইউ ক্যান লিভ নাও। থ্যাংক ইউ ভেরি মাচ, বেস্ট অফ লাক অল অফ ইউ।
থ্যাংক ইউ স্যার।